On.
Hi, welcome to Mathematics with Tom. I'm Tom, and today we are going to find the mean, the median, and the mode from a frequency distribution. So let's get started with that right away. So let's write this down. Today is the mean, the median, and mode of a frequency distribution. Okay. What I want to do is, first, I'm going to put up a data set that we've used before. We're going to make our histogram and from our dot plot and a histogram to create our frequency distribution. And then what I want to do is I actually wanted to compare the differences when we calculate these values from the actual data set as opposed to when we calculate these from a frequency distribution, and you see the differences and how reliable this method really is. So let's use our data set. We had this the other day. We'll call it data set. And let's use this. How about, I think it's like 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3. Okay, there's our first 2, 3. Our next row is going to be a 2, 8, 3, 4, 6, 2, 6, 4. 2 more rows. Our next row is going to be 3, 3, 8, 3, 2, 7, 9, 5. Our last row is 0. Oh, there's a 0 here. It's 5. 2, 8, 4, 1, 9, 7, 1. Okay, so this is our data set that we had in another video, but I want to use it again. And I'm going to go through this process a little bit more quickly this time. And we're going to make a dot plot from this. We're going to make our dot plot and the histogram. And we're going to use both of these. So let's make I'll make my dot plot here. I'm going to use kind of smaller dots, but let's see. We're going to have a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's label all these. 2, 3, 4, 5, 6, 7, 8. And I would encourage you at this moment to stop the video, use the data set here, and make yourself a dot plot. See if you get the same one that I do. Okay, and then otherwise, here we go. I'm going to make this for us. We have 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 8, 3, 4, 6, 2, 6, 4, 3, 3, 8, 3, 2, 7, 9, 5, 0, 2, 8, 4, 1, 9, 7, 1. All right, there's my dot plot. Hopefully yours matches mine. If not, I'll find out here in a moment. Let's check. So I'm going to construct a histogram here right beneath it. And we're going to make a histogram with 5 classes. And we've seen this before. So in other words, our bins are going to be 1, 2, 3, 4, 5. So our class boundaries form our horizontal axis. So let's label those. We have negative 0.5 to 1.5, 3.5, 5.5, 7.5, and 9.5. Okay, and let's check our frequency is our vertical column here. And let's make these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll go up to 13. I think 12 is enough, but we'll just check. Now, this is my frequency over here. I'm going to abbreviate frequency. And so remember now in the first class, from -0.5 to 1.5, there's 5 values. So 1, 2, 3, 4, there's my 5. So from here to here is 5. Our next class has 1, 2, 3, 4, 5. That's going to be 10, 11, there's 12. So let's put the 12, that's up here. And connect these. You don't have to use the dotted lines, maybe if you have a ruler. I use them just to help me keep track. And then let's see, my next group of 2 has 8. So 5, 6, 7, 8. And I go up to 5.5. My next group, let's see, those 2 and those 2 and those 2 has 6. 6 in the next group, that's right here. And here. And then my last group, it looks like, well, there's 6, 7, 8, looks like we have 9. And there we go. Now, I make that histogram. I think making the histogram is probably easier than actually constructing a frequency distribution straight from the data. But remember, from this histogram, we can quickly write our frequency distribution. So let's do that. We have class boundaries, we have frequency, we have everything that we need. So I'm going to make my frequency distribution from my histogram. So here's my histogram. And let's do this. Let's have our class boundaries. And I'm going to abbreviate B and D1S for boundaries. I'm going to have frequency. Okay, so let's make that. Those are the 2 main categories. If you've got that, all the primary information. So negative 0.5 to 1.5 has a frequency 5. Our next one goes from 1.5 to 3.5. That had a frequency of 12. Then from 3.5 to 5.5, we had 8. Frequency is 8. And then from 5 9.5 to 7.5. We had 6. So this one. And our last column has 9. Our last column has 9. That is 7.5 to 9.5. And that has 9. Now, I'm going to put a line under this. You might recall, now, before I let me finish one thought. My first thought is make sure you leave an extra column. We're going to need a little bit of column space. And we should at this point run a quick check. There's 40 data values. This should total to 40. Well, there's 20 right there. Let's see, 9 and 6 is 15, 5 more is 20. So 2 20s, there's my 40. So I didn't miss any data values. Now is where the problem gets more interesting. Are you ready? What I want us to do is I'd like us to do this 2 ways. The first thing I want to do is let's calculate the mean directly from the data set. So we're going to do that by hand. And I think we can do this if we work together here. So the mean from actual data. So I'm just going to call that one my capital, I'm going to call that my capital X bar. So the mean from, I'll call it the mean from actual data, so we'll just use it A. Equals. Now, let's do some work together here, because writing 40 of those numbers out is a lot of writing. And I have this pretty green chalk, so let's use that. Let's do some arithmetic here. Some mental math is always good for us. Socrates claimed it was the path to enlightenment. So let's see what happens here. I'm going to put a little sum column. So remember the big capital E, the capital sigma letter for sum? Let's just sum these rows, all right? Hopefully my cameraman is feeling his A game. Hopefully I am, and hopefully you are. And you can use a calculator. Let's add up each row. So 3, 4, 8, 9, 14, 23, 24, 25, 31.
Tom.
All right, there's a 13, 21, 30, 37, 49. Here's a 10, 17. 17 plus a 10 is a 27, 35. Hopefully this is what you're coming up with as well. Then we have, here we have 6 and 8 is 14, 17, 18, 19, and 7 is 26, 35. Looks like a 40 there. My last row, let's see what I have. There's a 10, 15, 24, 25, looks like a 7 more for 32. Okay, hopefully your calculator is doing this for you and you're getting the same results. I'm going to come over here and list those out. Let's add that up. We had, if I can see them, 31 and a 49. 31 plus a 49 plus 35 and 40. I have a 35 plus a 40, and I have one more row, total of 32. I'm going to put a line under all of that, so we have to add those still. And then when we're done with that, we're going to divide all of that by 40. See what we get here. Let's see how we do. Well, I'm going to combine these. It might take me a couple steps. You might be faster than I am. That's good, though. There's 80. 80 plus a 75. So that's 155 plus 32 more. It's 40. This is going to be 187 over 40. There's a couple different ways to do this. I'm doing this in my head. If I take 40 is 2 times 2 times 10. So let's trim that down. Half of 18 of 187, that's going to be 93.5 over 20. Ooh, half of 90 is 45, so it's 46.5, 46.75. I just took half of that. I reduced the 2. And then now divide by 10, that one I can do. That's 4.675. Okay, now if you didn't do the arithmetic in your head, that's okay. Please use a calculator. Please verify that this is in fact the correct answer. Now the question is the title. The question is the title. The title today is we're going to find the mean of a frequency distribution, but I just found the mean directly from the data set. And I have a frequency distribution here. So the question is how do you do that? Well, let's come over here and let's look at our picture for a moment. We can look at this first picture. Now let's use this pretty pink. Remember, we split this first, the ones and the zeros and the ones. We put those in this bin. We put the 2s and the 3s, and we put those in another bin. And so on, and we kept categorizing them in these different bins. What we do is once these data are put into a histogram, we actually, in this picture here, we have no idea how many of the data were zeros or how many of the data were actually ones. So we're now working from this picture. All this information is lost to you. What do? And the answer is we use the midpoint of that class. We use the midpoint of that class. So, in other words, to find the midpoint, it's just the average of two numbers. So what we do is we take the negative 0.5, we add it to 1.5, that gives us 1. Divide that by 2, and we get 0.5. So I'm going to come over here, I'm going to write that 2, so we have that. So what we do is, and I'm going to write it this way. We often, you might see the capital X for data, and we use an M on it for the midpoint of those data. Midpoint of the data. So what we did is we took negative 0.5 plus 1.5. We add those, we divide by 2, and we get 0.5. And now think of this. The class width here is 2. Well, if I'm starting right here, I'm going to move 2 units. That's going to be 2.5, 4.5, 6.5. But let's see if that works out with the arithmetic. If we take a 1.5 and we add 1.5 plus 3.5. We divide that by 2, that's going to be 4 plus 1 more is 5. Half of 5 is 2.5. Let's do one more. 3.5 plus the 5.5. I'm just using my class boundaries and I'm finding the midpoint. Divide that by 2, that's going to be 8. One more is 9. Half of that is 4.5. And the next one is going to be 6.5. And finally, 8.5. Now, let's do this. Let's find, I'm going to call this X capital F, or the X bar, X bar, the mean from the frequency distribution. Let's see what we get. So what do we add up? Do we just add up our midpoints? 0.5 plus 2.5 plus 4.5 plus 6.5 plus 8.5? The answer is no, we don't. The reason is why? Well, remember what we've done is we've said that any data point in this first bin, we're now representing it as a 0.5. Well, how many 0.5s are there in there? 5. So what you could think of, you could imagine, if this helps you, is you could think of, if you're right here, right in the middle here, is all of your data now are 0.5s, and there's 5. 1, 2, 3, 4, 5. There's 5 of them in there. So what we need to do is we have our datas are 0.5s, but we have to multiply them by 5, because there's 5 of them. Our next data, those are 2.5s. But how many do I have? I have 12. I have 12 of those, plus, then my next ones are 4.5s. How many of those do I have? I have 8. Oh my. Plus, then I have 6.5s. That's my next data values are 6.5s. And I have 6 of those. Plus, my next ones are 8.5s. And I have 9 of those. Now, we're going to take all of that, we're going to add it up just like you would expect, and we'll divide by 40. Okay. I'm going to use one more row here. I'm going to do a little bit more arithmetic here. Hopefully you've got your calculator ready. I'm going to do this. Hopefully it works. Well, half of 5 is 2.5. If I take 12 times 2.5, well, that means I need 12 2s, and then I need half of a 12, so that's going to be 24, and then half of 12 is 6, that's 30. This says I need 4 times 8 plus half times 8. Well, 4 times 8 is 32. 32, half of 8 is 4, so 32 and 4 is 36. 6 times 6 is 36, plus half of a 6 for 39. Plus, I have 9 times 8, that's 72, plus half of a 9, which is 4.5, so that's 76.5. And then again, we're going to add all those, and then we're going to divide them out by 40. Okay, this is going to be interesting. So x bar sub f from the frequency distribution. Let's add some of these up. I'm going to clean up the 76.5, add 2.5, let's call that a 79. I'm going to need to keep track of these a bit here. Plus, I think we can clean these up right here. 36 and 39 is 75, and 30 more is 105. And we're going to divide that by 40. So, this is going to be interesting. What are we going to get? 79 plus 105, that's 184 divided by 40. Whoa, that doesn't seem very close. Let's see, is it close? Well, again, remember 40 is 2 times 2 times 10. So if we take half of 84, that's going to give me 92 over 20. I can take half of 92, that's 46 over 10. And what dividing by 10, that one I can do with confidence for 4.6. Now look at the answers. Are they close? Remember, the rounding rule would say you round to the nearest tenth. So we would have rounded this up to 4.7. From our frequency distribution, we got 4.6. So you can see that even though we've lost some of the individual identity of the data in the histogram or the frequency distribution, it still gives us a pretty close idea of what the mean is. Okay, that was the mean. The next ones are the median. The median is next. So the median from data is, now, I think the easiest way to do this is to use your dot plot. Let's find our median from the data. The median from the data is, you could look at your dots, but let's do it another way. Let's do it this way. Think if you have 40 dots, then the middle of those dots would be 20 dots. And you'd have 20 in the lower half and 20 in the upper half. So let's go count 20 dots. See what happens. 20 dots. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's counting from the bottom. From the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And there it is. So the median is between those two fours. So there we go. Our median from our data set is 4. Now, imagine we didn't have the data set and we needed to find the median from our frequency distribution or from our histogram. Well, it's the exact same mental process. If you have 40 dots, or you know you have 40 data values, you know that the median of those data values is 20 in the lower half and 20 in the upper half. So let's think about that. If I'll work from my histogram. If I'm working here, this first bin represents 5 data values. Well, the median occurs after 20. So I would need to come to this next bin. This next bin has 12. Well, 5 plus 12. By the time I've looked at all of these data values, I've only looked at 17 data values. So I move to the next bin. If I move to the next bin, there's 8 more. So 17 plus 8. By the time I'm in this bin, I've accounted for 25 values. In other words, I know that somewhere in this third class is the median. So if we look at our third class, we're representing it with the midpoint. What is the midpoint of our third class? It's 4.5. And so that would be our median. The median from the frequency distribution is 4.5. So it's a pretty close estimate. The last one is our mode. And remember, the mode is the most frequently occurring. So mode from data is, well, we can see this easily. It's the dots that have the highest stack. 3. 3 is the mode. So let's write that. 3 is our mode. Record that. And then mode. Now, mode, it's no longer mode because now we're looking at classes. So we don't call it mode, we call it modal class. It's the class with the largest frequency. Modal class is class with the greatest frequency. And in this example, our modal class is the one with the highest frequency. It's 12. On the histogram, it's the tallest bar. And so we'd say our modal class is 1.5 to 3.5. Frequency 1.5 to 3.5. And if you look at it, notice that the actual mode was 3. 3 would be in that modal class, as we would hope. And I think that's where we'll stop. Thanks for watching. See you in the next video.